22 billion kilometers in over 40 years. That's the distance Voyager 1 has traveled since its launch in the late 1970s. The question is, how far can Voyager 1 travel? Will this probe one day reach a distant star system as humanity's first ambassador? And if so, will we possibly get an answer from there? The Voyager probes are regarded as milestones in space exploration, and they have provided us with never-before-seen images and impressions of the outer planets. That was supposed to be the end of it, but their mission has continued. To this day, can Voyager 1 really fly forever? And what will it see on this long journey? Voyager 1 flies at a speed of around 140 km and has long since crossed the boundaries of our solar system in 2012. Voyager 1 was the first manned object to leave the heliosphere and enter interstellar space. The identical Voyager 2 probe followed shortly afterwards. Since then, the two Voyager probes have been flying further and further into the open universe, each on completely different courses, and nobody knows exactly what they'll find there. We cannot predict whether the two probes will one day be discovered by a species that, like us, explores space and is surprised to see alien technical devices. The primary mission of the probes was to explore the outer planets of the solar system. In the 1970s, a unique constellation made it possible to send the probes on a uniquely short journey to the distant reaches of the solar system. Even back then, there were clever minds at NASA who thought it might be possible to send a probe beyond the orbits of Neptune and Pluto towards the Kuiper Belt. This band, over 4.5 billion km wide, is home to billions of rocks, asteroids, comets, and several dwarf planets as we know them today. But in the 1970s, when the Voyager mission was launched, little was known about this distant region of space. It took the two probes 12 years to reach the outer planets and another 10 years to cross the Kuiper Belt. Nobody knew whether the probes would survive the risk of collisions with rocks or asteroids was very high. But the two icons of space exploration overcame every problem and every task we set for them. For 45 years, the Kuiper Belt finally merges into the end of the heliosphere, the area from which the influence of our own sun slowly diminishes here. The probes were already about 18 billion kilometers away from the sun. Scientists call this area the heliopause. This area is characterized by the separation of solar and interstellar winds, and interested the researchers because of its unique properties. When Voyager 1 arrived there, 35 years had passed since its launch. No one would have thought that the Voyager probes would come this far, and they are still going on April 5, 2024. Voyager 1 was 2.39 billion kilometers from the Sun, and Voyager 2 continues its journey at 2.37 billion km. Where will they go next? And what surprises did researchers experience when the most successful probes of all time left the solar system shock at the edge of the solar system? It was really a shock when Voyager 1 was the first of the two probes to cross the final frontier of the solar system. The measurement data transmitted was very different from what was expected. The transition from the heliosphere to space proved to be like a thick wall, whereas simulations had always shown a smooth transition like in a lagoon. The flight through the unexpectedly hard threshold raised new questions about how the interstellar medium is really composed. Until now, all of our data about this region had been pure speculation. Shortly after the transition, Voyager 1 delivered real data from open space for the first time. And this is where the next surprise appeared. Although the particle density dropped dramatically as expected, there were still more particles than expected. This and probably a completely different pressure ratio at the transition to open space is very likely causing a buildup of particles and radiation in the interior of the solar system. Creating a dense wall, Voyager 2 confirmed the measurement results when it crossed this threshold years later at a completely different location. There, to the comparatively hard and abrupt end of the solar sphere was revealed. The heliosphere is a kind of protective shell for our solar system, formed from the sun's permanent streams of particles. It involves the star and all its planets in a protective cloak that keeps out the harsh interstellar radiation. At this magical threshold, researchers also hope to find out more information about the interaction between the solar system and the rest of the universe. Our sun is not stationary in space, but orbits with its entire system of planets, moons, asteroids, and comets through the galaxy we call the Milky Way. Just like a car moving through the air, leaving currents and exhaust fumes behind our star system, must also leave traces of the interstellar medium and interact with it. The Voyager mission is our first opportunity to explore this. Who would have thought that these two would fly forever? Would you have thought that these two probes could be humanity's longest-lasting ambassadors? Engineers assembled the probes in record time with a minimal budget. Time was of the essence, as a launch window was only open for a few years, and this opportunity of a conjunction of all the outer planets only comes around once every 176 years. The core of both probes consists of a robust, multi-sided structure made of aluminum and titanium. Both materials are known for their durability and resilience and have proven themselves thousands of times over against the harsh conditions of space. This durable and robust basic structure forms the backbone of the probes and made a decisive contribution to the mission's great success. The most striking feature is certainly the large dish-like high-gain antenna with a diameter of 3.7 m, like a listening ear. The antenna is always pointed towards the Earth. It enables the probes to communicate over incredible distances. A signal now travels for more than 2 hours with radio, now traveling at almost the speed of light. The signals are received on Earth by the Deep Space Network, a network of 3 high-performance antennas located in California, Spain, and Australia. The Deep Space Network not only transmits the signals from the Voyager mission, but is also used by NASA and other space organizations to communicate with distant probes or spaceships. Whether radio contact with the Voyager probes would continue beyond the Kuiper Belt was unclear at the beginning of the mission. The mission beyond the outer planets was a daring adventure, and it is nothing short of a miracle that the connection is still stable more than 45 years later. And at distances of more than 20 billion kilometers, the Voyager probes have already made indelible history here, and their mission will not be topped anytime soon. Of course, this long journey also required some kind of propulsion system for navigation and course corrections. In this case, these are not conventional thrusters, but small hydrazine swirl wheels that stabilize the probes and allow NASA to precisely control the orientation of the probes. In space, the actual propulsion of the probes can still be tracked back to the thrust they received from the rockets at launch in 1977. The probes then accelerated via various swing-by maneuvers on the gravitational fields of the planets they passed. Voyager 1 got its last big boost at Saturn. The speed and direction of the probes were repeatedly adjusted over the years using gravitational assistance maneuvers. So the probes do not require any additional propellant. They are now moving through space in a state of so-called free flight, which means they no longer need to be actively propelled to continue their journey. They glide through the vacuum of space, largely unaffected by the gravity of the sun or other bodies. And this flight will continue forever. But before we take a look at where they might end up, let's take a look at the design and finesse of the technical equipment and instruments. Both probes house a whole arsenal of scientific instruments that have been strategically placed above and inside the body, well protected by the robust construction and special radiation shielding. The instruments were capable of exploring the dense phenomena of space for an incredibly long time, from the first fascinating true color photographs of the outer planets to magnetic fields and the composition of interstellar particles. It is truly a feat of engineering that this technology has accomplished, and that it is still functional today. You can think of the technology like the old cameras that still work today. While modern digital cameras often fail after just a few years of use or are simply no longer supported, most measuring devices and cameras have been switched off for years in order to save valuable electricity. This comes from radioisotope generators, which convert the heat generated by decay of plutonium 238 into electricity. These long-term batteries will probably supply electricity for another 5 years or so, after which they will most likely go silent around the year 2030. NASA must expect radio contact to be lost forever. Then an era will come to an end. How far can Voyager 1 really travel? You've probably wondered where these two will end up one day. Perhaps you've also seen the movie Star Trek, the movie from 1979 in which a strange superintelligence with an initially indecipherable permanent radio message Vager causes excitement at the end of the movie. It becomes clear that Captain Kirk and his crew have stumbled upon an ancient human probe, and Vager turns out to be a distorted version of Voyager. This may well become reality. One day, it is possible that the probe will eventually fly into a distant star system and become stranded on a planet. However, it is much more likely that both probes will continue on their course through open space on their current trajectory. However, it will take them thousands of years just to pass by the nearest stars. Calculations have shown that this could be Glee, 445 in the constellation Giraffe, and Ross 428 in the constellation Andromeda, presumably. The two will fly on until they fall apart in a few 100,000 or even millions of years. Nobody really knows how the radiation from interstellar space in temperatures of around 273.15 DC will affect the material of the probes in the long term. Further stresses or particle streams which are rather sparse in space. We also cannot rule out the possibility of the Voyager probes encountering smaller ant rocks or micrometeorites, which over time will aid the metallic parts and make them thinner. The probes were bolted, riveted, and in places welded so far, this has withstood all the stresses. Incredibly well, experts estimate that at least individual parts of the probes will realistically be traveling through the universe as recognizable technical components millions of years from now. Should we humans one day be able to master faster-than-light travel, we could perhaps encounter the probes again somewhere in space, or they could one day be collected by a spaceship from another species. Inside the probes, these creatures would find an easy-to-play golden record. Then they would know who built the probes, how long they flew, and where they came from. We might then receive a surprising message from the universe. Click on subscribe now and look forward to many new exciting videos.